Donc la deuxième communication nous sera présentée par M. Westland, le thème gluten-free rice pasta produced by extrusion cooking quality, texture, sensory attributes, and microscopic.
Ladies and gentlemen, Assalamu alaikum. I have the pleasure today to present my communication entitled Gluten-free rice pasta produced by extrusion cooking quality, texture, sensory attributes, and microstructure. Pasta products largely consumed all over the world are traditionally manufactured from durum wheat semolina, known to be the best raw materials suitable for pasta production. However, gluten ingestion causes celiac disease in genetically susceptible individuals. Currently, the only treatment of the disease is gluten-free diet, based on the consumption of gluten-free products, generally made from rice or corn flours. But the replacement of gluten is a major technological challenge. And there are two approaches to replace gluten. The first one is the addition of ingredients or additives, and the second one is the application of the appropriate processing conditions. For this last one, extrusion cooking is one of the most suitable technologies for gluten-free pasta making. It is a high temperature, short time treatment which has many advantages, mainly low degradation of food nutrients, improvement of digestibility, and use of several raw materials. Thus, the objectives of our work were to investigate the possibilities of applying extrusion cooking technology in the production of gluten-free rice pasta, and to study the cooking quality, texture, sensory quality, and microstructure of rice pasta. Rice flour was used as raw material for pasta production. This flour was provided by the Verda company. Rice flour was moistened with water to obtain a dough with a moisture content of 30%. After a rest of 30 minutes, the dough was introduced into a single screw extruder cooker with 80 RPM of screw speed. Fresh spaghetti type pasta was obtained and then dried at 40 degrees Celsius. For pasta characterization, the first tests are cooking quality, which includes 3 tests. The first one, the minimum preparation time. 10 grams of pasta were hydrated in 200 milliliters of boiled water. Then, the minimum preparation time corresponded to the time of the disappearance of the white inside pot of pasta strand when squeezed between 2 plexiglass. For water absorption capacity, 10 grams of pasta were hydrated in 200 milliliters of boiled water. After the corresponding minimal preparation time, pasta were rinsed, drained, and weighed. And we use this equation for calculation. For cooking loss, both hydrating water and rinsing water were collected and evaporated. And the residue were weighed, and we use this equation for the calculation. For texture measurements, hard hardness corresponded to the maximum force needed to break a single bread of pasta, while firmness was the maximum force during compression of hydrated pasta, and the stickiness was the work required to overcome an adhesion between simple and self-material surface. For sensory evaluation, we have two tests. The first one is the sensory attributes. 15 semi-trained members assessed appearance, flavor, taste, and stickiness of hydrated pasta using a 5-point scale where 1 equals poor and 5 equals good. The same panel assessed the overall acceptability of hydrated pasta using 9-point scale, where 1 corresponded to dislike extremely and 9 corresponded to like extremely. And pasta with a mean score above 5 was considered as acceptable. For microstructure, we used scanning electron microscopy to characterize the surface and the cross-section of dry pasta, and the pictures were taken at different magnifications. In results and discussion, our results will be compared with those of wheat pasta. For minimal preparation time, the results indicate that rice pasta had longer minimal preparation time than wheat pasta. And this wheat pasta was produced by the same extruder cooker with the same conditions. On the contrary, we found that water absorption capacity and cooking loss were lower for rice pasta compared to wheat pasta. And this is due to the presence of gluten in wheat pasta, which absorbs more water. For hardness of dry and hydrated pasta, the same rice pasta has lower hardness of dry and hydrated pasta. The same results were found for firmness and stickiness. All sensory attributes were higher for wheat pasta except stickiness, which was found to be lower in rice pasta. The overall acceptability of rice pasta was 6.53, which means that this pasta was acceptable, but this result was lower than those of wheat pasta. The microstructure showed a smooth surface and a compact and homogeneous internal structure, which indicates that this technology, extrusion cooking, had a positive impact on the quality of pasta. In conclusion, rice pasta was successfully produced by extrusion cooking process, and it had good quality, including short cooking time, low cooking loss, and low stickiness. And she had also a compact and homogeneous internal structure. Finally, the nutritional quality of rice pasta can be improved using valuable gluten-free ingredients like legumes, vegetables, or other valuable ingredients. And thank you for your attention.